If I say the word laser, what comes to your mind? A science fiction movie? A laser pointer? Or maybe a laser weapon?
A kid flew right over me and blasted a car with its laser vision.
All these things associate lasers with heat and destruction, but did you know that you can also cool things down using lasers? Let's talk about Doppler cooling. Let's assume we have an atom traveling to the right at speed v with one valence electron. Doppler cooling is composed by basically three steps. The first one is a laser beam traveling to the left at a frequency which is resonant with one of the electrons' transition. In the second step, one photon of the laser beam is absorbed by the atom and the electron is excited to another orbital, adding a recoil speed towards the left into the atom. Then for step 3, a photon is emitted in a random direction and the electron goes to its initial state. Then, if steps 1, 2 and 3 are repeated several times during the emission of the photon, since the emission direction is random, there is no net kick of the atom related to the spontaneous emission. However, as illustrated by 5, the absorption of the photon is always in the same direction because the laser beam is pointing always in the same direction, giving an effective decrease in velocity, meaning that the atom is decelerating at a constant rate. By using Doppler cooling, the speed of the atom can be decreased by something around 300 meters per second to values close to 3 meters per second. But why is it called Doppler cooling? Well, we know if we have a wave and then we travel towards the wave source, then the frequency that we see of the wave is slightly higher. Then the key point here is that the laser beam that we send to the atom is slightly detuned with respect to the frequency of the electron transition, meaning that from the point of view of the atom, then the frequency is slightly higher and therefore fully resonant to achieve the Doppler cooling. What do you think about this cooling technique? Had you heard about it?